Hello and welcome to SP Calc Tutorials. My goal with this channel is to make AP Calculus AB topics as straightforward and clear as possible. We'll start with one of the most important foundational concepts in calculus, limits. Understanding limits is essential because they're the stepping stone to derivatives, integrals, and almost everything else in calculus. So what exactly is a limit? A limit describes the value that a function is approaching as x gets closer and closer to a particular number. The formal way we write this is limit as x approaches a of f of x equals a value. This notation means that as x approaches the value of a, the function f of x approaches this value. One important thing to notice is that the definition doesn't require that f of a actually equals this value. The limit is about the behavior of the function near that point, not necessarily at the point itself. So let's look at this graph. Suppose we have a curve and we want to know what happens as x gets close to some value, say x equals 2. If you trace along the curve from the left and right, you may notice that both sides are getting closer and closer to the same y value. That y value is the limit. This is the main idea. The limit depends on what the function is approaching, not what it equals at that point. So as x approaches 2 here, on both sides, y equals 4. So when does a limit exist? There are three main cases you should know. If a curve is smooth at that point, then the limit exists and equals the actual function value. If there's a hole in the graph at that point, the function may not be defined there, but the limit can still exist if both sides approach the same value. And third, if the left-hand and right-hand limits are not the same, like in a jump discontinuity, then the limit does not exist. Similarly, if the function shoots off towards infinity on either side, the limit does not exist in the usual sense. So here in this first image, it's smooth all the way through. So at each point, the limit will exist. And on this one, at that point right there, it's undefined, but it still approaches the same value on both sides. So the limit does exist. But here on the jump discontinuity, when it's approaching this value from the left, y equals 1, but from the right, y equals 2. So in this case, the limit does not exist. So now let's look at a numerical table. Suppose we want the limit of f of x as x approaches 2. If I plug in values close to 2, like 1.9, 1.99, 2.01, and 2.1, I might get outputs like this, 4.9, 4.99, 5.01, and 5.1. Notice that as x gets closer and closer to 2, the function values are getting closer and closer to 5. That tells us that the limit as x approaches 2 of f of x is 5. This example is useful because on the AP exam, you might see tables of values and be asked to identify what the function is approaching. So here's a very common mistake that happens on the AP exam, which is confusing the limit with the actual function value. For example, at a hole, the function can just be undefined, meaning there is no f of a. But the limit can still exist because the function approaches the same value from both sides. On the other hand, if there's a jump discontinuity, the left and right hand limits don't match, and in that case, the limit does not exist at all, like I previously mentioned. The AP exam frequently tests this distinction, so keep that in mind. The limit describes the behavior near the point, not necessarily at the point. To summarize, first, a limit tells us what value a function is approaching. Second, the function does not need to equal that value at the point itself. And third, limits can exist even at holes, but not when the left and right sides don't match. Thanks for watching this introduction to limits. If this lesson helped, consider subscribing for more AP Calculus AB tutorials.